Now this test problem on inverse function is a thinking and communication question. I'd like you to copy the question, pause the video, write down your solution, and then look into my suggestion. Question is, draw a relation such that its inverse has the following domain and range. Domain is x such that x is equals to -3, x is less than equal to -5, x is greater than equal to 3 and less than 8, and x belongs to real numbers. So that is the domain of its inverse. And range is y such that y is less than equal to -5, y is greater than 1 and less than equal to 4, y is greater than 6, y is not equal to 7, and y belongs to real numbers, right? Now, it is important to note that domain range is given for the inverse, right? And what you need to draw is a relation, not necessarily a function, right? So keep these things in mind and then write down your solution. Here is how I would like to do it. So let's read the question once again. What is given to us? It says draw a relation. So it's important we have to draw a relation, right? Not a function. Such that its inverse has following domain and range. So domain and range is given for the inverse, but we need to draw the relation. So what is domain and range for the relation? Let's write down that. So let's write down domain and range for relation. That is the first step, okay? And then we'll continue. So domain should be, we are given domain range for inverse. So what should be the domain and range for the relation? So now the domain for the relation should be, so it flips, right? So all these values which were range for the inverse become domain for the function. So let's write down that at x such that x is less than equals to -5, 1 less than x is less than equals to 4, x is greater than 6, x is not equal to 7, and x belongs to real numbers. So that becomes the domain, okay? And what is the range? Let me write range here as, so this becomes the range for the function. So it becomes y so that y is equals to -3, y is less than equal to -5, and then we write 3 less than equals to, y is less than 8, okay, and y belongs to real numbers. So that becomes the range for us, right? So this is the first step, and I hope if you have read the question properly, you got it right. Now let's figure out how to include all these conditions. So I'm using light ink here. We have a very light graph paper anyway. So domain is that x is less than -5, less than equal to, so this is -5, so this means we are looking for something on this side. Is it okay? This is not the function I'm drawing. I'm just writing or making a kind of help lines so that I could include the function. So I'll teach you a method of really sketching a relation from the given condition. So first is, let's analyze the domain. It says x is less than equals to -5, so that is 1, right? On a number line you can say, well, these are my points included for the domain. Then we have x which is greater than 1 but less than equals to 4. So 1 is not included, so let's say this is 1 and I'm putting a hole there, and 4 is before 5, so we'll just fill it up. So that becomes another part of our domain. And then we say x is greater than 6, anything which is greater than 6, not including 6, right? That is there, but x is not equal to 7 also, so 6 is included, 7 is not included, so we have a hole there also, right? So that becomes the domain for us, right? Now let us analyze and write down what is the range for us. So I'm using light colors here just to help me out so that finally I can sketch the graph. Now range is that y is minus 3. So minus 3 is 1, 2, something here, right? So somewhere here y is okay. Then y is minus 5. So this point is included. Minus 5 is kind of included, right? Less than minus 5. So everything which is less than equal to minus 5 is included. Y is between 3 and 8, including 3. That means 1, 2, 3 is included, but 8 is not included, right? So 5, 6, 7, 8 is not included. So that is, so I'm just saying, well, this is part of my range. Okay, so that is what my range is. Now I have to draw a relation which fits into all these conditions, correct? So let's draw the relation. So one thing is kind of easy. There is more than one solution to it, right? Now let's start all over again. Minus 5 is included and we have y which is less than minus 3. So it's a good idea to just draw a line saying like this. So this means this is at minus 3, okay? So this is minus 3 for us. So we have, met this criteria. Now it says that y is less than equal to minus 5 and we can select whatever domain we want, but let's take the last one. We say including minus 5, right? Now this is the part of our domain. So minus 5 is included and 8 is not, and y is 3 to 8, right? So let's take 3 to 8 first. 3 to 8 where 3 is included but minus 5 is not included. Okay, so we say y is between 3 to 8. So this 3 and 8. Okay, now since this part is not included, so what we will do is add 3, we'll put this function 8. 8 is not included, right? And for x equals to 4, let me take the value at 3 here, which is included. Now, in that case, if I join this up, do you see that? So this is like 3 for us. Do you see that? So what I have done by doing so is that I have included 3. Do you see? I have included 3 and I have excluded 8. And as far as the domain is concerned, so I have included this part. As far as the domain is concerned, I have not included 1, right? Not included 1, but have included 4. Do you see that part? So that is how I can meet this criteria. Now I have another condition here, that is x is greater than 6, but it's not equal to 7. So greater than means here, and we know that we have to include 5, but somehow, okay, so and this is r. So what we will do is this kind of tricky. So y is less than equal to minus 5. Let's go to minus 5 and we'll start at 6, but we'll not include it for the time being, right? Since 6 is not included, x is greater than 6, right? Now here what we can do is, and 7 is also not included. It says x is not equal to 7. So 7 is not included. Let me just draw 7 here and let me just draw a line here. So that line indicates that range of less than 5 is included. Do you see that? Is that okay? So that is how we can draw this part, but still one condition has not been drawn, and that is y is less than equals to minus 5. So that part has not been drawn. So what we can do is that at minus 5 we can draw some point which is in our domain, right? So like domain is everywhere here, so minus 5 we can put a point here. I'm purposely putting it here to show you that, well, whatever I have sketched is not a function, but it is definitely a relation. Do you see that? Now you can read it back. If you analyze from here, you can say, well, now the domain is less than equal to minus 5, okay, and in this case domain is from 1 to 1 is not included, 1 to 4, 4 is included, and x is greater than 6, well, 6 is not included, that is 6 for us, and this is 7. Is that okay? 7 is also not included, right? But x is greater than 6. Anything to the right of 6 except 7. Do you see that? So that arrow kind of shows anything to the right of 6, but not 7. I hope that helps you to figure out how to sketch a function given domain and range of its inverse, right? So I'd like you to draw this function in a different way. Well, this is one of the solutions, right? You could actually give many different solutions for the same situation. So try it out. I hope you appreciate these guidelines which I made earlier to indicate domain and range, right? That helps because that kind of gives us a framework where we can fit in our function or relation in this case, okay? I hope that helps. You can subscribe to my videos and look into very interesting questions on similar topics. Thank you and all the best.